Good morning,
Good
bears.
Oh, jeez.
We are on the last topic of acids and bases, and so I want to take a look at how we calculate it. Now, in the past, we typically teach how to calculate pH, concentration, and also pOH and concentration of hydroxide ions, but we're not going to get into all that, so we're going to try to keep it super simple. First of all, you need to remember that this is all based on this idea that we have a scale, a pH scale, of essentially 0 to 14. When we have in neutral, meaning not acidic or basic, would have that substance would have a pH of 7, and the only the sure example of a substance that has a pH of 7 is what we call DI water or deionized water. It means it's just pure water, there are no ions in it. If you turn on our faucet, it's loaded with all kinds of minerals, especially our water, because it's comes from the Edwards Aquifer, which is limestone, and anyways, so we can talk about that another time. But deionized water, pure water, has a pH of 7. A substance, again, this should be review, a substance that's a strong acid is over here on the closer to 0 side. So over here would be a strong acid. Okay, so I wrote this out. Here we have strong acids. Strong acids are closer to the 0. So an acid that could even have like a 0.5 pH. That would be a strong acid. The smaller the pH, the stronger the acid. Over here, if we had, let's say, a substance that had a pH of 6, well, it would be classified as a weak acid. It's more closer to being neutral, so that would be weak. And then right on the other side of that 7, let's say we had a substance with a pH of 8. That substance would be considered a weak base. And then, of course, over here, the scale goes all the way to 14. A pH of 14 would indicate a very strong base. Theoretically, all substances have a pH and a pOH, essentially. And so if the scale is 14, what we could say is the pH of a solution plus the pOH of that same solution should equal 14. And so if we want to highlight this for you, because the whole scale is 14, and we see 14 pop up again here. All right. So let's just kind of take a look at this. And some of these you can, I'm going to work this first page. I'm going to leave the second page for you to complete. And let's see. pH, concentration of hydrogen ions in aqueous solution, can be measured on a pH scale, and we just reviewed what the pH scale was. Something that's neutral would have the same concentration of hydrogen ions and hydroxide ions, which is what I was trying to explain right here using this basic scale. Values that are greater than 7 would be considered basic, and less than 7 would be considered acidic. And so it's just asking you here in this to specify if it's acidic, basic, or neutral. I would look some of these up, but they're kind of interesting. If you go back to the PowerPoint that I had posted at the very beginning, these are all labeled, but just type in, what is the pH of seawater? Just do a little search. What is the pH of seawater? And then whatever the pH is, if it's acid, then you would put an A. If it's if it's if you find out the pH is between 8 and 14, well then seawater is basic and you would put a B. If seawater is 7, it shouldn't be 7. Then you'd put N for neutral, okay? So there's that one. All right. Now another calculation that, so I do want you to do 1 through 4 here. Okay. Another calculation that we can do is calculating concentration of hydrogen ions. I could take the pH of a solution and calculate how many hydrogen ions I have. And the way that we would do that normally in a classroom, if I was calculating for concentration, it would look something like this. So this little bracket here is indicating concentration. And so I'm saying the concentration of hydrogen ions here because this is going to determine if the substance is acidic or not. So the formula to determine the concentration of hydrogen ions using pH, we would do 10 raised to the negative pH. So basically what I would do is, let's say I had a substance that had a pH of 6. In my calculator I would do 10, and then I would do raised to the power of negative 6. That would calculate and tell me how many hydrogen ions we have. Now to go back the other way, let's say I wanted to know what the pH was. That's my unknown. And I only knew the concentration, then we would do a different calculation and we would do negative log times the concentration of hydrogen ions. This can also be done for hydroxide ions and for POH, but we would use POH and hydroxide ion concentration on and on. We're not, normally, in a normal school year, every single year I've ever taught chemistry, I've always taught these formulas. And like I said, we're in a slightly different situation. So I'm going to show you a couple tricks so that we don't have so much work to do and just try to keep it simple as possible. Let's take a look at number 5. Some of these didn't come out too well, and so I'm definitely going to work these with you. But what it's giving you here is the concentration of hydrogen ions. So it's giving us this, and it's asking for pH. It's asking us basically to use this formula right here. Let me highlight that. Okay. And then it's saying based on whatever our pH is determined to be, we'll say whether it's acidic, basic, or neutral. If you are familiar with algebraic terms as far as using log and inverse log, and I know some of you are like, oh my gosh, I've never done log, I don't even know what log is. It's fine. We don't need to go into understanding how log works. There were many scientists that worked for many years calculating this, and there are still some flaws to it. It's not entirely perfect, but it's just kind of a standard system that chemists use to make these determinations of classifying all solutions as being acidic or basic. And we don't need to go into that kind of scientific theory. We're going to keep it simple. So here we have, and some of these came out kind of weird, we have 1 times 10 to the negative 4th molar. Remember that word molar? That was from our solutions unit where we were talking about concentration. And we're looking at concentration of hydrogen ions. If you were to put this in your calculator, which in your calculator you would do negative, you would press negative, log, and then you would put 1 times 10 to the negative 4th. We don't need to do that. This number right here, this little exponent right here, it's telling us what the pH is. So for a substance that has, excuse me, for a substance that has a concentration of 1 times 10 to the negative fourth, the pH is, very simply put, 4. And so if we looked at 4 on the pH scale over here, 4 would be between 0 and 7. And so then we would say that this is classified as an acid. Easy, right? That's not bad. All right, take a look at the next one right underneath it. Very simple. It says a substance that has a concentration of 10 to the raised to the negative 10. Well, we're just going to use the little exponent there. And the exponent is 10. That's our pH, 10. In trying to determine if it's an acid or a base, 7 to 14, here it is. Here's where it falls. So we're on the side of the scale that would classify a base. And so here we're going to say B. I'd like you to try those other two right there. That's not bad. I know my calculations probably scared you off and you were like, whoa. Or like I said, I'm going to keep it simple for you. All right, now here's the other thing. We are going backwards. So it says use the pH to find the concentration. So now the formula that we would use here is this guy. Let me highlight it a different color so we're not getting confused. I'm going to highlight this for you so you know to use that formula. And I should go back and do this one here so you know which formula to use. All right, and we're going to keep it simple again. Remember, in these problems over here, we were doing, okay, what's the pH? If I have 1 times 10 to the negative fourth, then my pH is 4. Well, how do you think we're going to do that for here? Same exact way, we're just doing it backwards. If I have a substance, in this case, stomach acid, that has a pH of 1, well, then my concentration would be 1 times 10 to the negative 1. And that's my concentration. Let's take a look at B. Rainwater. Rainwater has a pH of 6. And we're going to do it the same way. 1 times 10 to the negative 6. And that's it. I want you to try these out. This page is exactly the same as the other page. And when we write in scientific notation, that's what we were doing. So in these problems, let me get my little pointer here. In these problems, it's giving you concentration. These are concentrations, but they're written a little bit different. They're not written in the 1 times 10 to the da-da-da-da-da. I want you to try doing that, though. Scientific notation, in this first example, let's see. We're not going to worry about that one column. So let's see. 0.001. When we're trying to determine that in scientific notation, I'm going to start off with my 1 times 10. Why am I using 1? I'm using 1 because my number in this problem is 1. Down here, it's going to be different. You're going to use 5 because that's the number there. Okay, so anytime you're trying to convert a number into scientific notation, we're trying to get it down to 1 digit. And here we have 1, 2, 3 digits after a decimal. So we need to move our decimal over to the left, sorry, to the right, to get it to a whole number. And so to do that, we're going to count how many times we have to move it. So we're going to do, let's see, I'm going to do it over here. So the number is 0.001, and you've seen me do this before, so this should just be review. We're going to move it over 1, 2, 3. So we had to move it over 3 times in order for it to be 1, basically. And so to account for that, 3 times was how many times it was moved? It's going to be -3. So 1.0 times 10 to the -3rd. That's our concentration. We didn't do any calculation. All we did was convert our number from a number into scientific notation, which is typically how scientists would do this anyways. And so we had to move it over 1, 2, 3. So we have 1. The 1 comes from our number in our, what it gave us, 1. Times 10 to the -3rd, which is how many times we had to move over our decimal. So that means our pH would be equal to 3. Would that be an acid or a base? It would definitely be an acid. Definitely be an acid. For these problems down here, it's asking you based on the indicator. We have several indicators that we use to determine acids and bases. One indicator is litmus, and there's very basic litmus paper. For example, there's just there's like red or blue. So if I just put it in a substance, if it's an acid, it's going to turn red. If it's a base, it's going to turn blue. It's not going to tell me anything else about it. And then we have pH paper, which is a little more complicated. It actually has a range of colors and is a little more specific to telling you or showing you what the pH is by using a scale. And so like if I had litmus paper, I put it in, let's say it turned kind of a greenish color, then I'd compare it to the scale that they give you, and I'd say, oh, okay, that's a base. So that's what litmus is. The phenolphthalein is just another indicator that we use. This is a liquid indicator, whereas litmus is paper. This is a liquid indicator, and so you would have your solution, and you take a couple of drops of this indicator, and then again you're going to end up with a certain color. You compare it to a scale that they give you, and then you're like, oh, okay, it's red, or it's kind of an orange color, so that tells me it's an acid. So this is all it's asking you to do here in this one, is to state based on the pH, is it acidic or not? That's all I want to know. And you could do that right here. You could do that by just doing the pH scale. I just don't want you to be like, what is litmus? What is phenolphthalein? Remember the pH scale, 0 to 14, with 7 being neutral. That's all I want you to do. All you're going to tell me is, are these acids or bases? All right, guys, that's a quick, very watered down version of calculating pH and concentration of hydrogen ions. I want you to complete the problems that I didn't complete. There aren't a whole lot, but I'll give you several days to do this. I hope you're doing well, and please email me if you have any questions. Make sure you're staying on top of your work. Before you know it, the school year is officially going to be over, and some of you, a lot of you are doing just such a wonderful job just making sure that you're turning in your work and taking care of your business, and so I appreciate that. Alrighty, that concludes our acids and bases unit, and our next unit will be gases. See you guys later.